So thank you very much for coming at this late end of the day. I know we're almost through the day, but how's it been for everybody? Good? Good, okay. Well, I'm really pleased and grateful that Gary Clark, our CTO, came up here to share the story around our data center transformation and some of the things he's gone through. So since we've had that time, Gary, I'll just kick it off. We did bio, so
okay.
I'll skip that part, but thank you so much for being here.
Okay, welcome. Can you all hear me okay? Good. I'll try not to stand in front of this lectern the whole time, but just for the minute to get myself orientated, we'll start. So what I've come to talk today is a little bit about our cloud journey as a public company. We are, roughly speaking, a $5 billion annual revenue group, and we're about 9,000 people. Employees, we have a couple of thousand, probably contract staff distributed all around the planet. We are a US corporation, and we have a significant research and development office also in India. So we have about 2,500 development engineers building our products, which are routers, switches, and firewalls, and associated software around those products. So that's who Juniper is. I am from internal IT. I'm the IT CTO. I'm also the engineering CIO, which basically means I look after the technology requirements of that development team with respect to IT. So who's moving to the cloud? This is some 2013 data. It's even more, the numbers get even bigger when you look at the most current. I have this as a reference point because that's when we committed to, in Juniper, we committed to the cloud in a 2012 start of journey. And so we're in year 4 of our move to the cloud. I'm going to speak to you dominantly about how we move to the public cloud for the corporate applications. And I'll go on then to look at some of our engineering work, which is almost exclusively in a private cloud. In there for different reasons. It's a very particular environment. So in the public cloud, which much of what I'll speak about today, but I'll also speak to some of the flavors of who those hosted providers are, if you want to think of it that way. You can see here the scale of the numbers are quite astronomical. The public cloud being dominated at the moment in terms of first place by Amazon, but obviously there's significant many other players in that market, IBM, Microsoft, Google, etc. I'll touch on those where relevant as I go through the deck. So looking at the cloud, first I'd like to do is to frame it so that you understand how we chose the journey and how to move to the cloud. There's a lot of mystery or mystique around parts of the cloud which don't make too much sense, but there certainly is some mystique around it, and there's a lot of misunderstanding around a couple of areas. One is around security. The other one is around, if you like, data availability, and which I think is critical in many of the public sector environments. And I'll try and give some numbers that I've bumped into as I've gone through this study and implementation. So the study is no longer a study, just to let you know, 85% of Juniper runs in a public cloud environment. So that's pretty significant. We're not a company that was born in the cloud. So some of the newer companies only know that way of operating. So, but we've come from a traditional data center, etc. arrangement through to this hosted. So when you look at the cloud, I put together this journey, which I wrote a sort of specification, an outline architectural draft in 2012 for the application architecture to move to the cloud. And we chose our shopping list in this hierarchy. It's very important to understand the difference between SaaS, PaaS, and infrastructure as a service. The glorious part about the software as a service model is you get rid of most of your problems. If you're used to running data centers here, you have the opportunity to move much more flexibly and to always be current in terms of software. So you simply consume it. It's a true service model. There are many famous examples of this. One of the early ones clearly would have been something like Salesforce.com. More recently, Microsoft Office 365 as a service. I'm sure many of you use Microsoft Office products in your day-to-day work. Then into platform as a service. Here, you have to do at least configuration. You may be doing some programming. In the first one, it's purely configuration. and in many cases perhaps workflow engines around it. In the platform as a service, you still own big chunks of the application performance and how it looks and runs because you're still programming it. But all the middleware, the database, typically, and clearly all the physical pieces of the component are provided as a service to you. So some of the big benefits here is that you can build on it relatively quickly. There's no setup time. The provisioning time is a software-oriented time scale. So there's none of this waiting for service to turn up over 12 weeks, provisioning and putting them in some data center, clearly. And the same applies to the infrastructure platform. But more than that, you can essentially do the same with the software and all the middleware that sits there. So in our case, we have SAP on platform as a service. So our financial system, our customer relationship management system sit on those types of platform. And then finally, infrastructure as a service. I guess Amazon here is probably the one that's most well known, certainly widely deployed and growing fast. Not stepping over Microsoft or Google as well, who are clearly massively significant in this space too. Big advantage there is your system's always patched, it's always current. There's none of this, it's Tuesday, it's time to update your software and get the thing to work so you can't get attacked when you're not ready for it. The vendor takes account of all of that. At least there's some value in that piece. And it gives you the ability to be relatively flexible and flex systems up and down. I'll speak to some of those applications. And the little towing underline there, in a secure environment. I would have said in the early cloud journey you couldn't rank all of the platforms as equal. It's certainly in terms of security. Some players do it in a very different way. So you'll need to observe those, and I'll speak to some of that in terms of our method as we go through. So vendor review, for want of a better way of putting it. So the journey begins for us was when I came to the company in 2011. We had 18 data centers, various sizes, from full-blown 100-plus racks, proper data center, down to just a few servers and file servers and print servers and exchange servers out in the field, so distributed computing. And the proposition that I put together in the early days was to build on the one cloud application that we had when I joined the company, and that was ServiceNow. That's the help desk ticketing system. Some of you may use that. I don't know. And the first target system was to look at Salesforce.com. It wasn't built at that time, but that was our first move to business value outside of IT. The proposition then in the move to cloud, I set the target, and this is how I wrote it originally, a 0 data center footprint. In other words, those 18 data centers were to go to 0 in 4 years. That was the target. And the plan was backed and approved the middle of 2012, and middle of 2016, we're 85%, close to 90% in the cloud at this point. So we're actually making really good progress. More of that in a moment. One of the things I did look at was that when you have this notion of moving your applications to the cloud, the SaaS applications, that cloud, where it is kind of unknown to you, but it tends to be unique. So if it's Salesforce.com, it's in a Salesforce.com cloud architected data center. If it's Office 365, it's in a Microsoft Office data center. And so you have to have this notion of some of these applications may actually talk to one another. And so you have to think about the cloud interconnect, and that's what that bottom line's about. So when you think of that, certainly at this point, there weren't really good architectures to support that. So I looked at our own corporate wide area network, which is a global one. It operates in about 50 countries. That interconnect, you need to look at and categorize. This was our approach, or my approach, to categorize what connectivity you need between these various clouds and the offices that they serve, whether it be a large business critical site. Perhaps an analogy here for some of you in the state business might be, is this a 911 class service, or is this nice to have at the other extreme, and then all manner of services in between. And so in these 5 tiers, we decided what availability we needed, and that then defined what level of connectivity or duality or availability you require in these sites. This is actually one of the most critical points. It always seems quite trivial when I put it here, but there's an awful lot of people say, oh, that's a really good idea. And it's about that classification. And for us, it was a kind of a business risk thing. And you can see it's around scale. You know, these are like a regional sales office. So for us, that would be something like Amsterdam or something. It was a pretty important office to us in Europe. Or it could be further down the list, there'll be Moscow and smaller sites. And then within the US here, we have quite a few small regional sales offices where teams can get together and work, or customers may come in and look at products. So this classification is quite important. And the same applies then to cloud services. At the very top, the core data centers and what we call POPs, points of presence. These are these connectivity nodes that says from here, I've got an internet connection, or I've got a direct connection to Amazon, or I've got a direct connection to this serving data center, or to this service, or a partner. Those are the most critical. And then when you've got large sites, like this convention center would probably be in this tier 1 site. And for us, what we did here, I don't want to bore you with an overcomplicated network model. Essentially what it shows is there's a red and blue network. So over the same physical network, we could connect multiple business units at different types of service. So that, I think it would be analogous to a shared WAN that the California state can share, and yet the data rides on the same physical hardware but maintains splendid isolation between the two. So in our case, if we do a merger and acquisition, when we bring on something new or a new service, or you don't want service A to interfere with the bandwidth available to service B, say 911 over, I don't know, community college chat network, you wouldn't want an overloaded chat network to blow away a much higher level service. So in the connectivity model here, we layered on this notion of it's called VRFs, but virtual routing forwarding tables. It's a way over one physical to have lots of logical networks and maintain auditable, which is pretty important if you're in any way in sort of financial services area, auditable differences. So that was the model we took. And ours, to get high availability, Verizon, AT&T, no surprise, two of our biggest customers, two of our suppliers here. And that network, we started up in, I'm going to say it was September 2012, and it's been on. And so the head of the network team's about to shoot me at this point, but it's 100% availability core. I'm kind of proud of that, I guess, as I wouldn't say it, but I say the head of network always wants to shoot me every time I say it, because you've freaked it out now, it'll fail tomorrow. And so the network for us looks like this at a simple level. It says for every major area, for this, I know this is a map of the world that perhaps plays differently for the state of California, but the principles apply. It says for each major zone that you want to cover, you need a primary and a secondary site, probably no surprise. And the same applies in Europe. It's London and Amsterdam. And in Asia, I know there's 3. Well, it's actually really Bangalore, which is in India, and Hong Kong. Australia's there because it's a long way from anywhere. If you've ever flown to Australia, it's quite a ways. And for us to get the quality of service of delivery, because we run voice and video on this network, we had to put a point of presence there too. It's not required architecturally, but it was required to get the class of service to a place that's a long way away. The map, as you probably appreciate, distorts the amount of distance it really is to get to Australia. It's a long way down and under. So that was the nature of it. And in these locations, there's a POP. This is where there's an internet connection, all the security feed and analysis you need. It's got wide area connections. And so that enables you then to decide what class of connection of service you need to the cloud, whether it's a high availability service or otherwise. And then a colleague of mine joined, our CIO, so I'm the IT CTO, the CIO joined and helped me simplify my statement around zero data center footprint with a cloud architecture. He said, you mean, why not go to the cloud? And so we adopted this phrase, why not cloud? It's quite important because it kind of puts the boot on the other foot. Because it says every time you touch an application, reconsider it for movement to the cloud. Is it economically viable? Would it give me a better service? Would it give me better disaster recovery? Would it improve my availability? Those are the sorts of things one would consider. And this proposition, Juniper moved to the cloud. there's a lot of people say, oh, move to the cloud and save money. Well, that's one thing you might do it for. We actually were looking to improve our availability and our agility of the application set. We bolted together our own application set, and it was becoming a very large and unwieldy to manage. So for us, that was about 300 core applications. There's a lot more than that, but 300 that really enable us to do our job every day. You come in, the sales team can phone in, and the field teams can get a quote, build an order, propose that order to the manufacturing gets it out the door. A customer can call in and say, hey, I've got a bug, can you help me with it? We can ship a product if it's failed. So all those kind of processes that enable our corporation to run need high availability, and we wanted to improve our business continuity position. So my model was to go from only one application with full business continuity to every application with business continuity where it was a critical application. And of those 300, 150 were in that bracket. Today, 150 applications have full disaster recovery and full continuity at zero extra cost. So I've effectively doubled that. You can think of it simplistically, I've doubled the data centers, but I actually held the cost the same. It's different than that, but that'll do as an approximation. So our model to move to the why not cloud was cost, security, benefits, and who was the provider. So this cost model obviously is something we need to understand. We had to understand our current way of operating it versus what they would charge us. The security analysis had to be done, so our CISO had a kind of a check sheet, a typical audit sheet that I'm sure many of you use when you're looking at security products and services. What benefits they may or may not bring with the service offering, whether it be SaaS, PaaS, or infrastructure as a service. And then the provider. This was pretty critical in the early days because some providers didn't make it, and some that are here today won't make it. So there's a risk there that you need to think about. I don't think Amazon or Google or Microsoft or IBM are going anywhere, but there are many niche players in the early days, many of whom haven't made it. So provider viability was another criteria. And so in the context of, it's dominantly an on-premise model today when we started this activity, and then 4 years ago, but today dominantly in the cloud. So where are we at actually today? What I say is that 30% of our apps, and I give you some sampling of what we've got. Office 365, I think most of you know what that is. That's the Microsoft desktop and mail and secure mail and messaging services. We actually have Link as well, so we use enterprise voice, etc. That's all operated or managed by there, but the voice part of it is actually an on-premise service. So each one of those JPOPs has got a voice and video server in it. So in each region, we've got a pair of voice and video servers. And then Salesforce.com, you saw that for ServiceNow was our original application in the cloud. Another example is Concur, that's an expense management system, and Coupa is a procurement type tool. And then our rebuilt SAP systems, which is the core of our company, financial systems, customer reporting, and so on. 55% of that, and that's the big chunk of our processing, is done in a platform as a service cloud. And then out of interest in the infrastructure as a service cloud, the one that actually gets a lot of the press in many regards, we have our PeopleSoft application in an IBM data center, and in Amazon we have currently the plan of record is 72 applications running in there. So here's about 150 apps, and then here's about 150 apps of that 300 that I mentioned earlier. So that's our ended up dispersion. So half of the apps are 85% of our process load. So those were the optimum ones for us to consider. I often used to call the ones on the right the left behinds, the apps that didn't make it into category 1 or category 2. So for us, what do we actually achieve in terms of physical? Well, we had 18 data centers. Some of those were closets, so 6 were full-blown data centers, and the other 12 were like connectivity services, so just a few racks where you needed it. It was dominantly physical servers. We were less than 20% virtualized. And it was about 450 racks. And I say no cloud presence. I'm being a bit unfair. We had one cloud app, ServiceNow, that I mentioned. Today, we shut 17 of the data centers. For us, that was important because they were distributed. They were hard to manage in many cases because they were spread all over the planet in some cases. This made our life a lot simpler. The one data center we have left is 92% virtualized. And that's a mixture of VMware, Solaris containers. Those are the two main virtualization platforms in that legacy environment. And we're down to just 30 racks. And so that's about 2 rows of chairs. Runs that plus the cloud runs Juniper. And today, majority cloud-based. Yeah, I would suggest we're a bit north of 90% there. Again, these were some of the bigger players. And in our, what did we actually achieve in the WAN redesign? We went from best efforts and 99.5% uptime, which means 8 hours a month something's not working. Probably doesn't work for some of you. In some of your jobs, you probably get called out all sorts of the hours. We have 4 nines uptime as our target. The WAN core is actually 100%. The WAN edge varies based upon those availability figures. Dual provider, we tripled the bandwidth, and the price went down. Because we have 2 suppliers, they're going to, how that goes. You get the suppliers will beat one another down to the lowest possible target. So it's a healthy environment, and it's very, I would think in some of your areas you have to make sure you've always got 2 quotes, have to accept the lowest quote in many cases, those types of rules. This is a real benefit of reconsidering how that's built and operated. And in the local area network, for campuses or sites, since we did look at those to get the availability and the throughputs that we wanted, we adopted it's a flat network. There's no block links, so there's no spanning tree for those who are into networking. We don't. That's kind of like cursing at Juniper, spanning tree. Try and avoid that. It's managed as a whole, so when the network administrator looks at this campus with 2,500 people, they look like they're looking at one big switch. That's how it looks. 2,500 ports, and you've got one desk, and you sit at it and drive it. So that's quite an advantage. And we do 0 administration on our network. So you walk along the wall and you plug a phone into some miscellaneous point. And it says, oh, just a minute. In the core of the network, it automatically recognizes it's a phone and gets put onto the phone network automatically. Or if it's a user, or if you turn up and try and use our network, you'll automatically get set to the outbound network interface. So again, this was all about lowering our cost of administration and making the campus as easy to manage as the network. You kind of ignore it. So really what I want to say, in our journey, what we learned was really that the cloud's not actually innovation, it enables the innovation. It's enabled us to simplify our design. It's enabled us to improve our availability and improve the quality of the service end to end. So that's pretty significant. I'm going to look now just briefly at what are we doing for the engineering. I told you this was for the corporate piece. So there's all those business applications there was us to quote for and build and supply product to customers like yourself. But the people that actually do the design of the software that runs on those boxes, they're all actually run in-house. And it's an early story yet, but we're commencing. And these were some of I put together a proposal, JDI's Juniper Development and Innovation Department, also known as engineering. So there's 2,500 people in the core of that, plus the test team's probably about another 500. So there's about 3,000, nearly a third of our staff are in product development. And the cost of our labs was incredible. I can't really give you the numbers, but it was growing at an uncontrollable rate, so the CFO was always after everybody. We're trying to get shorter time to market, develop software, maintain it better. And we wanted, everybody wants a stronger presence in the marketplace. And The head of engineering says, hey, look, I want better product quality. I want to get it out the door quicker. And I want engineers to want to come and work here. I want it to be the place to work. So make it fun. We had a traditional environment. Essentially, in the campus, we had 19 data centers called labs. If you walked into one, it would look like this room, and it would be full of computing, and it would be roaring at you with all the noise of a data center. And we had 19 of these things just in one campus alone. We were trying to move also then from these 19 labs, they're almost like little fiefdoms rather than one collaborating lab. So bringing them together, we brought together these different methods that we used to employ into more unified ones with standardized tools and higher throughput. So those were the, if you like, these were the business requirements of the network. So these multiple labs down to just one. So the way I describe it is, if you want to store water, 19 puddles is not the way to do it. It's much better to have one lake of information or one lake of compute. We had 19 puddles, and it was necessary and efficient. And the operating cost of those labs were $850 million over 10 years. And we, for I think I said 300, it was 297 million. But we've reduced the cost to be spent over the next 10 years by $300 million by building a cloud fit for purpose using current technology that scales out. How big is it? Well, it's got these 2,500 developers, 500 test engineers, and 200,000 virtual machines in it. And those 200,000 virtual machines fit in this one room easily. So the power and cost savings, and yet are dramatic. We also moved it to a place where power was cheaper, but that may not be possible with the state of California, I suspect. But it was important saving. So one of the things to consider in the private cloud is it efficient and is it economic? It's often too easy to say, I'm going to build my private cloud security to be simpler. Will it be? I'm not so sure. Some of the public cloud providers, the premier ones, the names I've already mentioned, offer tremendous security issues. You can buy so if you're in healthcare, you can buy a HIPAA-compliant Google Drive. If you're in financial services, you can get a OCC-approved storage system. If you're in our type of world, we can get SOX compliance from some of the vendors. So there's all manner of certifications and security that I would argue in some cases these suppliers can do better. I will just give you the closing story as a little pitch. This was the idea behind this deck. Cloud-based solutions and ongoing innovation, if you want to pull that off, what we were trying to do, you saw I was trying to get to full disaster recovery, and yet I couldn't get any more money to do it. I couldn't double the number of data centers or double the amount of compute. But by spinning off some items to the cloud, I lowered my operating budget, enabling me to buy into other ideas. That generated me to a pool of money. With that money, I generated more good ideas to improve actually performance. So this cycle closes down. So in fact, we're close to completing the cycle, and we've gone from a non-compliant, non-SOX compliant, non-security, not a very good security model to an improved security model, high availability, in a much more flexible manner. So this was, for us, is the big win. With that, thank you for listening to me. So if there are any questions around what we've done and some of the more specifics I can speak to, I know a lot of the detail if people are interested, or I can chat with you afterwards if you would like. So I'm Gary, if anybody wants to raise any questions.
Any disadvantages?
Say again?
Disadvantages of the move?
They're hard to think of. Two learnings that initially turned potentially into disadvantages. If you move an application to Amazon, you have to consider three things, not just the cost of compute and storage, but the cost of I/O, input and output from the cloud. That's the tax that you pay for moving data out. Data going in is not charged, it's part of the service. Data out costs you money. So you have to think very carefully around that. And there were a couple of early estimates that were done poorly. I would say that was a method problem rather than a disadvantage. It's something you have to think about. Not all applications are best served in a public cloud environment. Many are. I would argue most. I can't say all because that wouldn't be accurate, but I would say the percentage is really high. So there's one, if you want to think of it as a disadvantage.
What about just security access?
I think the premier cloud providers spend more per CPU on security than I can afford. So I think in the security model, I think it's a bit of a myth that security is worse. I believe it's actually superior for most, in many cases. For example, if you take the security of data, not cyber security, but the assuredness that data is never lost. Amazon, for their S3 buckets, to use their terms, that's what they call them, it's 11 nines availability. 99.9999999. I can't possibly imagine how I could afford to do that. They can because of the scale and the way in which they store the data, and they spray it everywhere, and so it's highly distributed and unlikely to take a loss. So I think in terms of data security, I quoted Amazon. There are other examples for different providers, but that's one I happen to know. So
I'm also just more in terms of access. So there's data security, but in terms of accessing the information.
The security model varies per platform. We have a virtual private connection into Amazon and use VPC inside that, and we use our own software products inside to secure it. So I can have a product called a vSRX. SRX is the name of a Juniper firewall. It could be somebody else's. But that virtual SRX enables me to drop a firewall exactly where I want it. The advantage of a software-based model in that style of environment is I can drop little ones all over the place and really make the environment quite awkward to get into from an attack perspective. Yeah. But no, you have to engineer that appropriately. For other providers, like with our platform as a service provider, I actually implemented again their security model, but I augmented it with a couple of our own devices in their environment because they were amenable to that. Depends what security angle you want to take. There's cyber threat and attack. There's financial loss, reputation loss. In our case, our biggest, for Juniper, our biggest threat would be intellectual property loss. Somebody steals one of our algorithms, which is unique to us, and that has value to somebody else who might pirate the software or tamper with it. So those are areas that we're very conscious of. In other areas, I worked in financial services for 4 years. There, data integrity would be a big thing. The numbers are what they say you are. CalPERS, as an example, is a big, massive pension fund that used to be managed by Barclays. I actually worked at Barclays when we were the major fund holder. Security of data there would be critical in that case.
And you were trying to access your own, is right? And I wanted to
Sure.
understand the question better. If you have Amazon, how easily can you get access to your?
Yeah, I think it's more, you're at home, you can access information through the public internet as opposed to when it's on your intra-local area network.
Yeah.
But sure, you can use the VPN as a
Yes, exactly. A large number of the services you have in the physical world are available in this virtual world too. It's a matter of stringing the services together in an appropriate fashion and understanding what the operating environment looks like. And we have, as you can tell, we have many suppliers, but not too many. I guess one of the other disadvantages could be is you don't want too many suppliers. There's no point having for every application having a different cloud provider. In the SaaS world, that's how it is typically, although many SaaS services are actually operated on Amazon or Google or Microsoft infrastructure data centers, but you see them as a SaaS service. In some cases, some of the SaaS services you consume as an individual, you have no idea where they are. They're there virtually somewhere. And in many cases that wouldn't matter, but some of the more advanced providers now have location opportunities too. In other words, you can force it to be in a particular environment. Maybe not state-based, but certainly country boundary-based. So for example, I know Amazon's building a data center in Germany. There's one in Amsterdam, for example, to meet some of the European regulations and so on. Yeah. Yes, ma'am.
What about staff that were responsible for the data center?
Yes.
So what happened?
To them.
Were they repurposed, retrained?
Yes.
Were they laid off? What happened?
Yeah. So I would say there was two major categories there. There was one was self-selection, and one was cross-trained. Per se, we've made actually, in my IT group, we've made nobody redundant, actually. So what do I mean by, let me answer that in two parts. So I said self-selection. There were some people that could see that maybe they were a storage engineer. Now that storage is in Amazon, and therefore there's no dials for you to twiddle anymore. You can't be a storage engineer. So some of those individuals did self-selection and said, actually, I like doing this piece of work. That's what I do, and I want to stay in that environment. And they went and joined Amazon, or they joined Microsoft, or they joined Hewlett-Packard, or whomever's operating these cloud services. So some of them who could see that their role perhaps was going to be under pressure, a few of them did that. It wasn't a large number. And then the majority of migrated their careers. They have new titles. I have, like, rather than a storage engineer, they're now an infrastructure engineer, or they're a cloud services broker. That means they help perhaps manage the cost side of Amazon services. Other technicians and engineers went on to be integration engineers, because to connect these services, that's the new important skill, because you've got a cloud with a service and a cloud with a service. Well, they've got to communicate. That integration needs to be operated and managed and monitored. So in some cases, they changed roles. So those were the two dominant factors. And to be honest, I didn't have anybody that didn't get a role or self-selected, I think. So our IT group, to give you an idea, is about 350 people. So about 200 of those are in infrastructure, and it's still around 200 today, but many of them are doing different jobs, right? Because remember, I was going to have to double my servers and stuff, so actually there was a lot more roles to be filled to operate the newer environment and to manage it. And a lot of it can be down to financial or integration management. Any other questions? Okay. With that, thank you for attending. Hopefully something was useful. And feel free to come up and grab me at the drink session later if there's anything you want to ask one-on-one. Be happy to chat with you.